My bad.
Okay, we'll start today's class. This week we are going to focus on NumPy arrays. This NumPy array is almost the synonym to manipulating data. Last week we talked about the 4 compound data types in Python: list, tuple, and dictionary, and the set. So why do we need the NumPy arrays? So NumPy array in general, it only supports data of the same type, which uses much less memory to store the data, and that's the first reason. And the second is NumPy allows creating n-dimensional arrays, and it's easy to change the shape of the array, let's demonstrate it with the code. So here, if I create a NumPy array, so this is a one-dimensional array. And I can easily change this shape to a 2-dimensional array. Like this, or 3-dimensional array. But with a list, you cannot do that. And the third, NumPy array allows executing mathematical operations, so which, in contrast to a Python list, where you usually have to use a loop through the list to do the mathematical operations, which means, for example, here. Okay. Too many. Here. Mathematical operation. So here I have the array A, and I have another array B. Okay. Add these 2 arrays together, and it will output. The output result will be the 2 arrays added together with individual number. However, if I use list, let's see what will happen if we do this operation on a list. So it doesn't support. Okay, I didn't create a list. I only had a range. So I create these 2 lists first. Now let's see. So if I do the sum operation on the list, it will append the list B to list A instead of adding each element together. So if we want to do this on this list, you probably have to write a for loop for I in the range, the length of the list, and then add a list A1 to list A list A1, list A1 to list B1, and add the individual number together. So this is very convenient. Imagine later we have to change the table, like add a column, a price, add a column equals the price times how many purchases equals the total total revenue. Then you can easily generate that column, additional column. And also, it's very easy to locate elements in NumPy array. So if I want to find, the where is 3 in this array, or I want to find all the numbers larger than 5 in array A. Now I can just do this. It will return all the elements that are larger than 5. And if I want to get all the non-zero in the array, it also gives me all the numbers that are non-zero. You can count. Yeah, it did including the 0, so it's correct. Okay, these are some advantages of NumPy array. And so first, let's try to create some arrays. We mentioned it allows us to create one-dimensional or multiple-dimensional arrays. So for one-dimensional array, I already showed this. Just let's go back to see what it looked like. See, this is the array, and inside it is a kind of like a list. And if we go to the two-dimensional array, see how it composed of. It composed of one-dimensional arrays, and the one-dimensional arrays lined together forms the two-dimensional array. So if we check the shape of A, it shows like this. And if we check this shape, let's create a two-dimensional array. So if it's a one-dimensional array, it shows that this just 10 elements, and if it's a two-dimensional array, it shows the row number and the column number. We can assume if it's a three-dimensional array, what the shape will look like. We'll add another number, shows the third axis. Okay. So we just created a one-dimensional array, and if we do a two-dimensional array with a NumPy range, and we have to do what we did is first we do one-dimensional array again, and as I said, when we do two-dimensional array, we line up, have another. Just look at the shape, have another one-dimensional array, and then group them with the bracket. So let's and then we group these one-dimensional array together. And you can imagine what will be the output, what will be the shape of this two-dimensional array. It will have how many rows, how many columns. Okay, what's your answer? No, it will be two-dimensional. This one is a one-dimensional array, like the A we generated, and now we are trying to create a two-dimensional array with this method. So we use a one-dimensional array and then added the second one-dimensional array, and then grouped them with the bracket to form the two-dimensional array. So you can imagine the output of this will be this is a one-dimensional array from 0 to 4. This is another one-dimensional array from 0 to 4. So this two-dimensional array will be how many rows, how many columns? 2 rows, yeah, 5 columns. So this will be the output. Here I leave 2 questions for you. We will do this in class at the end of the class. So if I change this statement to this, what will be the output? And also we'll try to create a 3D array by yourself. You can imagine the 3D array. 3D array, the shape of the 3D array will be a one-dimensional array is a line, and two-dimensional array is a table, and a three-dimensional array is formed with multiple tables from top to bottom, and this is the axis 0. So these are the tables. These are the tables from the two-dimensional array table, and then these are grouped together, stacked up together from top to the bottom, that forms a 3-dimensional array. So we already showed the shape of the arrays for one-dimensional, two-dimensional, and be careful of the axis. So this is the axis 0 is the row, and then axis 1 is the column, and in here axis 0 is the number of tables. Let's show it. Let's get a number. Another. Okay, and I want to reshape it into a 3-dimensional array. I can do it with 2 tables, and in each table I have 2 rows, 5 columns. Let's see, it will look like. But you see, this is the axis 0. The number 2, this one. The first one is the axis 0. It shows that it has 2 tables from top to bottom. This is the first table, and this is the second table. And in each table, there are 2 rows and 5 columns. So yeah, at the beginning it will be a little bit hard to understand, but when you get to work on it, it will be clear to you. this 3D array, and also we can create an array with random numbers. And in here, you can just define the shape of the array to generate this array with random numbers. For example, three rows and 4 columns. It will be a 2D array with 3 rows and 4 columns. And on Wednesday, we'll talk more about a random number because it's often used when you have to create a sample from data. And this is the only week we have time to talk about it, to mention it. Okay. So we just use the NumPy arrange. I use the NumPy arrange. So what is NumPy arrange, and when do we use NumPy arrange, and when do we use range? As you have seen, NumPy range, when I use NumPy range, it's pretty the same as the range method in Python. You use the start number and end number and then steps, and also be careful, it excludes the end number here. So the first difference between these two methods is range is a built-in function and a range is a NumPy library. So whenever you use it, you have to include this NumPy library. And the main difference is range returns an iterator, and instead of list, and NumPy range it quickly creates an array. I just had an error at the beginning. You see, range. If I do this, it returns this data type range. We probably didn't mention. We mentioned it at the beginning. Range is a data type in Python, but it's not a list of numbers from. It's not a list from numbers from 0 to 9. If we want to create a list with this sequence number, you have to redefine this as a list. And then it will be a list. So if you just use a range 0 to 10, it's just an iterator. And for NumPy range, it quickly gives us an array with the sequence numbers. And so because this range function returns an iterator, it's more convenient when you have to use it for the for loop. For the for loop, we often use a range to iterate from number 0 to 9. But with a range, it returns a list. It returns an array. You cannot use it as an iterator. Okay. Another feature of NumPy array is that range function only generates integer values, and the NumPy range supports other data types. Example here. If I want this range to have smaller steps, like 0. Just want to have 0.1 each step, and let's see, it doesn't allow us to do that. But with NumPy range, we can it with the float number. It gives an array with 0.2 at the steps. And you can also specify the data type for the array. For example, I want to this, and you can still use the one step, and then I define the data type to float. So you see, that's different from the previous array we created. This is the float numbers. So these are the main differences between range, the method, the built-in function range, and Numpy range. Since we created some arrays, the common thing we had to do is to select some elements from the array. First, how do we select a single element? It's pretty straightforward. In 1D array, you just point out the position, and in 2D array, you point out this is the row number and the column number, and same with the 3D array. This is a 0 axis, so it means that we have several tables, right? Several tables for the 3D array. So this is the number of the table, and then the number of the rows and columns. And be careful of the position. Again, this the first element, the position for the first element is 0, right? So this one should return the false number. It should return the false number in the array. So, I'll leave these for you to practice in your assignments. Okay, and I'm going to move forward to talk about slicing. Sometimes we have to select an area from the array. So how do we do that? This method. So here we selected a single element, and this method is kind of the similar from how we use range. So we get the start number and the end number, and then the steps. Let's try this. So in the array 8 again. Let's use array 8. I want to select the first maybe the first 8 numbers. So I just type in the start number is 0, and then goes to 8, and then step is 1. Then you can skip this, so that will return you the first 8 numbers. And if we want to use this for slicing it on 2D array, what you do is this defines the first axis, the columns, which columns you have to select, and then the second part defines this defines the rows you want to select, and the other part, the other half defines the columns you want to select. Let's try this again. So let's do an example. I want to select 2 and 7. How do we do? How should we do that? So I'll do The rows, I want to select all the rows. You can leave it blank probably. And I want to select which column. Oh, let's try this group. Okay, this group, 4 numbers, 2, 3, 7, 8. So start number should be a 0, 2, right? And the end number should be a 2, 4. That because it exclude this end position. And can skip the steps, or just one step. And let's see. Okay. So it doesn't allow us to skip the first axis, the yellow axis. Okay, just return say. Try some other numbers we want to get. Phase 1. I want to get the numbers from just the 7 and the 8. What should I do here? The start position should be. No, this is 0. I want to get 7, 8. So, yes. Line 23, this one.
Yeah, what those like the way you wrote the like positions.
Yes, yes. So my goal is to get these 3 numbers. Right? These 4 numbers, 2, 3, 7, 8. So we selected the entire both rows, all the rows. So I didn't define anything. I skipped it, and it will select all the rows. I only have to define this is the like we did at the shape. This is the yellow X. This defines the rows, and this defines the column numbers. Right here. So what is the start position of this? Start position of this is a 0, 1, 2. Start number is a 2, and the end number is a 2, 3. But because the end number is excluded, like we use a range, it's excluded. So I had to write a number 4 here, and the steps is a 1 step. Yeah, 1 step usually, right? If you want to select like this group and this group, and then you say step 2, right? So this returns this. If we change this to 3, what will be returned? Yes, just this column, only this column. Right? So now I want to select just this one, 7 and 8. What should we do? We define the column. The column is correct now, but we have to define the row numbers. The row numbers. It should be the start position is 0, 1. The start position is 1, and the end position you can just skip it. It should return this. Okay. Everybody else? Yeah. Good on this now? You're good on this? We'll have time to practice toward the end of the class, and then we'll see what problems will come out. Nice. Okay. We have more practices here. More chance to practice here. These are questions I leave to you. So you try to write the code to select a single row. For example, I want to select just 1 row. What should we do? You can skip the column, the second axis, the column, but we define the row number. And also, or if we want to select the rows in all the numbers, should we you can skip the start number and number, but define the steps. And also you can use negative number to output a row from backward. For example, I select this row and output from backward, use a negative number 1, negative 1 to output from backward. So we want to slice the 3D array. See, this is the code. It's a sample code, so we'll build it output. Sure. Let's just look at this picture. So if I want to select this group here, this group here, how should I write this code? Should be array. So as I said, we have 3 axes, and the first axis decide which table are we going to select. Here we want to select the first table, so I do 0 or 1, 0, yes, and I can skip the, no, I have to define the end number, and on the number is 1. You only want one table, and then we select the rows. So the rows I want is okay, both rows. So I can just skip the row number, and if we want to select the first 2 columns, should we write it here? The start number should be 0 again, and the end number should be 2, and the steps is just skip, and the default step is 1. And that will give us this area. So you can later, when you practice, you try to use the random method to generate a 3D array and run this code to show what this will generate and how we slice out this area. Okay. The last concept that we are going to introduce today is a kind of what we learned about kind of the same as mutable and immutable to list and the dictionary, those Python data types. So if we assign a number, we want to reassign some numbers in this array. Will this work? Let's try it. Still have A. Okay, we still have A. I want to redefine some numbers in A. Does that work? From 8 to 5 to 8, and I want to assign them to Y. It worked, and let's print out A again. See, it did change the. It did change the element. So we can say NumPy array is mutable, right? You can change the elements in this array. And second one is when you slice out the array. Let's try this. Create an A slice. Slice equals do the first three numbers. And then I assign the values to the slice, not to A. Slice equals slice equals the list. So I redefine the slice. I pick out some elements and assign this to the slice. And this slice is correct. This slice is correct. And when we recheck this array A, no, it didn't change the A. It's different from the code we have here. So if we take out this number, size. So should be everyone. Let's try this again. Yeah, I only redefine give value to one element in slice. And let's recheck the A. So now the difference is let's look at the code we output for the first time, and now here this A slice, I assigned a new value to one of the elements and it output a new array. And the array, this array is built from A. It's a view from the A. And when you change this slice, also change the original source A. And what I did for the first time, I create another slice. Yeah. To the last numbers. These slices should be from 7 to 9. It should be these two numbers. And assign this to so this is just a number. It's different. Oh, I assigned a new value. So B becomes this integer number. That's what was wrong. But if you still think B is like here, if I still treat A as a slice, so I sliced out, I assigned one value to this slice, and this A slice is still an array. That's the difference. Still an array from A, and then this slice, when you change the value in the slice, they also change this array. Okay. So, but if we only want to change the slice, but we don't want to change the original source, what should we do? We create a copy of the original array. So here I can see slices. Okay. value. Let's see if it works. So this is the C slice, and we created based on the copy of the A. And if we do run A again, obviously it didn't change this number here. Okay. So we have to be careful. When you assign new values to a slice, it could change the original source also. Okay. Next is practicing time. We had some question. We left some question on the slide. The first is try this code and to see what will be the output and explain why we have this output, and try to create a 3D array. Okay. And second group of question is here. Create a 2D array and try to select a single row or column, and also select the rows in all the numbers. Last one is use negative number to output a row from backward. And third group of questions is create a 3D array and try to with random numbers and try to slice out this highlighted area. Or we can work in groups. Two of you form a group, and I'll ask each group to answer one question. Let's get to work. Practice makes perfect. Only when you practice, you can understand these concepts better. We all have a laptop, and we can move and form a group. Yeah. Oh, you completed all these questions.
Mhm.
You can move forward to work on your assignments this week.
Work on but this doesn't work.
Yeah.
Because they're different sizes.
Yes. Yeah.
Oh,
No, should have the same. Did you? Were you able to?
I'm sure they the last one.
Oh,
right. Unless you make like. Oh, shit.
Oh.
Yeah.
So, and it's really brush. So,
So you just have to write out. Two chickens. So you can't be. Two.
Yes. questions.
Here.
Yes.
Showing two-dimensional indexing 3, so it's saying it's going here.
So would you want that top one?
Sí. Yes.
So it means like you have,
Because it's not changing it.
Yes.
You
have
just
to-
reshift. You gotta actually change it. Okay,
Yeah, you have to reassign it.
that makes sense.
5.
So if we just
You get this row.
Reassign it
this
there.
row, and then my row. Not
Just
the
do that.
the odd number.
Yeah. Okay.
Yes. Okay. I think we'll summarize these questions and see if anybody have any question on this. Are we all good on these two questions? The first one is when you define a 2D array, the rows should be line up. If a 2D array it should have the same the first one has 2 elements and the second one has 4 elements. It will not work. Create a 3D array. This 2D array. So you want one group of this and another group like this one, and then you group them again. So this is a 2D array, right? We use the 1D array, formed a 2D array. And if you want a 3D array, you need one more group like this, brackets, and then you add another bracket, and that will be a 3D array. Bradley mentioned a good problem. So when you reshape, I'm sorry, when you reshape the array, for example, when you reshape a 1D array to 2D array, it doesn't change the shape of the original array, but you have to reassign it to a new array in order to change the source. And these questions. So this code and this code, it generates the same result, but these two array, yeah, no, that worked on this one. This two code, it gives you the same result, but the array is in different dimensional. One is 2D and the other is just a 1D array. Select a single row or column. You just yes, 2D array. Single row or column. You just define the row. Here, if A is a 2D array, and I just want to select a single row, then you can give it a start number, end number, a start number, end number, for example, I want to select the first row, then I do this start number, end number, and then the steps. And select the rows in odd number. The steps should be two, just should be two, and the end number you can skip that. That will select in all the rows, but the odd number rows. And the negative number to output a row output a row from backwards. For example, I select the first row, and if I want to let's just select this whole the whole array, and then output the rows from the backward, and just add a negative number to output the row from backward. And if you want to output a row, just one row, you define one row. Like that should give you a row and from backward to the front. So this one, look at this code. This code should select 0 to 2, so it should select both. Should select both table, and then this one is the 1. Position is 1, so position is 1 is this. Position is 1 is 0, 1, so it should give you the second row, right? This should give you the second row. So it should give you these two rows. Because I selected both table. It should give you both these two rows, both table, and the first row, second row, actually, second row, first, third column. So it should give you return you these two numbers if you did it correct. This code. Let's see. This code here. I should give you the bottom number in from each table. Does that make sense? And this area, did we already do this area? This area should be just do one table. So 3 axes. And the first axis is a table, so we only have to select the first table. This. And then the rows, you want to select the 2 rows, so do 2. And the first 2 columns, so you have to select 0 to also 2. Sure. That gives us this area, highlighted area. Are we all clear on this, or do we need more explanation? We can talk about it after the class if we need more explanations. Next week we'll finish the remaining concepts about NumPy array, and also we'll talk about random numbers.